Our second lesson in Chapter 6 is on transforming and combining random variables. We'll take a look at performing a linear transformation on a random variable, combining random variables, calculating the resulting mean and standard deviation, and calculating and interpreting probabilities involving combinations of normal random variables. In section 6.1, we learned the mean and standard deviation give us important information about a random variable. In this section, we'll learn how the mean and standard deviation are affected by transformations on random variables. In Chapter 2, we studied effects of linear transformations on the shape, center, and spread of a distribution of data. Recall, adding or subtracting a constant to each observation adds a to the measures of center and location, does not change the shape or measures of spread. Multiplying or dividing each observation by a constant b multiplies or divides the measures of center and location by b, multiplies or divides the measures of spread by absolute value of b, but does not change the shape of the distribution. Pete's Jeep Tours offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run. The vehicle will hold up to 6 passengers. Define X as the number of passengers on a randomly selected day. The mean is 3.75 and standard deviation is 1.090. Pete charges $150 per passenger. The random variable C describes the amount Pete collects on a randomly selected day. The mean is $562.50 and standard deviation is 163.50. Compare the shape, center, and spread of the two probability distributions. Notice they're very similar. When we look at the histograms, the centers, of course, are different in terms of values, but look at how similar the histograms really are. Here's another example. El Dorado Community College considers a student to be full-time if he or she is taking 12 to 18 units. The number of units a randomly selected college student is taking has the following distribution. Here's a histogram of the probability distribution along with the mean and standard deviation. So our mean is 14.65, standard deviation 2.06. Tuition is $50 per unit. So here's the tuition charge versus the probabilities. Here's a probability and histogram of that distribution. To find the mean, we take each value, just as we did in the last lesson, times the probability and add them all together. Standard deviation, take value minus the mean, squared times the probability, add all those values together for each one, and square root it. Notice, 1. Shape of both distributions are the same. The mean is 50 times bigger than the mean of the first value, and standard deviation is 50 times bigger than the standard deviation of X. How does multiplying or dividing affect a random variable? Multiplying or dividing, you multiply or divide the measures of center and location by b. It multiplies the measures of spread, range, IQR, and standard deviation by absolute value of b. It does not change the shape of the distribution. Multiplying a random variable by a constant b multiplies the variance by b squared. So consider this. If Pete has it costs him $100 per trip to buy permits, gas, and a ferry pass. Here's the profit versus the amount that he collected from our previous example. The mean is 462.50 and the standard deviation is 163.50. So notice the standard deviation remains the same, the mean is different by $100. So interestingly enough, we consider what happens now. Here's another example. Back to the El Dorado Community College. If we add $100 plus T for student fees per semester, the standard deviation and the mean are the following. Mean is 832.50, standard deviation is 103. So we notice the shape of the distributions were the same for this one as the one before. Secondly, the mean is $100 larger, and the standard deviation is the same as the deviation of that T was when we originally looked at the other. So adding and subtracting adds A to the measure of center and location, that is the mean, median, quartiles, and percentiles, but does not change the range, IQR, and standard deviation. And it does not change the shape. So if we look at y equals a plus bx linear transformation, the probability distribution of y has the same shape as the probability distribution of x. The mean is a plus b1 times the mean of x. That's the mean of y. Standard deviation of y is absolute value of b times the standard deviation of x, since b could be a negative number. In a large introductory statistics class, the distribution x equals raw scores on a test is approximately normally distributed with a mean of 17.2 and a standard deviation of 3.8. The professor decides to scale the scores by multiplying the raw score by 4 and adding 10. To find the variable y to be the scaled score of a randomly selected student, find the mean and standard deviation. Well, since y equals 10 plus 4 times x, the mean is 10 plus 4 times mean of x, which is 10 plus 4 times 17.2, or 78.8. The standard deviation is equal to 4 times the standard deviation of x, which is 4 times 3.8, or 15.2. What is the probability a randomly selected student has a scaled score of at least 90? Since linear transformations do not change the shape, we look at 70, 8.8, and 15.2, that's our mean and our standard deviation. Find the standardized score for 90. 90 minus the mean divided by standard deviation of 15.2, 0.74. We look at the probability z is less than 0.74, which would be 0.7704. We want to know the probability there's at least 90, so we take 1 minus that to get the area to the right. So that will be 0.2296. So 22.96% probability. What if we have 2 or more random variables? Let's investigate the result of adding and subtracting random variables. Let x equal the number of passengers on a randomly selected trip with Pete's Jeep Tours. Y is the number of passengers on a randomly selected trip with Aaron's Adventures. T is x plus y. What are the mean and variance of t? So the mean of x is 3.75 with a standard deviation of 1.090. For y, the mean was 3.10 with a standard deviation of 0.943. They average a total of 6.85 passengers per trip. We can generalize the results as the following. We add the two means together to get the expected value of t. In general, the mean of the sum of several random variables is the sum of the means. How much variability is there in the total number of passengers who go on Pete and Aaron's tours on a randomly selected day? To determine, we need to find the probability distribution. So here's another example. The El Dorado Community College has a campus downtown specializing in a few studies. Full-time students at downtown only take 3 unit classes. Let y equal number of units taken in the fall semester by a randomly selected full-time student at the downtown campus. Here's the probability distribution of y. The mean distribution is 15 with a variance of 5.04 and a standard deviation of 2.3 units. If you were to randomly select one full-time student from the main campus and one full-time student from downtown and add the number of units, the expected value would be 14.65. That's from our previous example for x plus 15 that we just obtained, so 29.65. The only way to determine the probability of t is if x and y are independent random variables. If knowing whether any event involving x alone has occurred tells us nothing about the occurrence of an event y alone, and vice versa, x and y are called independent random variables. Probability models often assume independence when the random variables describe outcomes that appear unrelated to each other. You should always ask whether the assumption of independence seems reasonable. In our investigation, it is reasonable to assume x and y are independent since siblings operate their tours in different parts of the country. Consider all possible combinations of the values of x and y in our example. So this is total number of passengers, t, versus the probability. Recall that the mean of x plus the mean of y was 6.85. And the variance 2.0775. So the variance of x squared is 1.1875 and the variance of y squared is 0.89. What do you notice about the variance of t? Here is another example going back to the El Dorado Community College. Here's the probability distribution of the possible outcomes s of x plus y. So here's the mean of s and the standard deviation variance of s. We take the mean of x plus the mean of y, which is the 29.65, and standard deviation variance, in other words, first we have to figure out if x plus the variance of y was 9.63. As the preceding example illustrates, when we add two independent random variables, their variances add. Standard deviations do not add. For any two independent random variables, x and y, if t equals x plus y, the variance is the variance of x plus the variance of y to get the variance of t. Remember, you cannot add variances unless the two random variables are independent. They can never add standard deviations. Find a mean standard deviation of the cost of tuition, fees, and books for a randomly selected student in El Dorado Community College. So we would take the mean of the first, 832.5, plus the mean of B, which was 153, and add them together. The standard deviation cannot be calculated since the cost for tuition and fees and the cost for books are not independent. Students who take more units will typically have to buy more books. Another example, at the downtown campus, full-time students pay $55 per unit. Let U equal cost of tuition for a randomly selected full-time student at the downtown campus. Find the mean and standard deviation of U. So to find the mean, we're going to multiply 55 by the 15, which was the mean of y, 825. Standard deviation, we have 55 times the 2.3, 126.50. Calculate the mean and standard deviation of the total amount of tuition for a randomly selected full-time student at the main campus and a randomly selected full-time student at the downtown campus. So we take the mean of 732.50, which was the mean of t that we calculated earlier in an example, plus the 825 from this example to get our total. But we take the variances, so that would be the variance of t from our previous example, and the variance of u, which was taking this value and squaring it, and then we can take the square root to get our answer. Remember, you work with variances, we do never add standard deviations together. So in summary, for any two random variables, if the difference equals x minus y, the expected value of d is the mean of x minus the mean of y. The mean of the difference is the difference of the means. The order of subtraction here is important. For variance for any two independent random variables, the variance of the difference is the sum of the variances. If a random variable is normally distributed, we can use its mean and standard deviation to compute probabilities. An important fact about normal random variables is any sum or difference of independent random variables is also normally distributed. Example, Mr. Starnes likes between 8.5 and 9 grams of sugar in his hot tea. Suppose the amount of sugar in a randomly selected packet follows a normal distribution with a mean of 2.17 and standard deviation of 0.08. If Mr. Starnes selects 4 packets at random, what is the probability his tea will taste right? We want to find the probability it's between 8.5 and 9. So if we take and add the values together, so each of the means, we get 8.68. We take the standard deviation and square it, add them together, and then take the square root, we get 0.16. We then take our values, 8.5 minus the 8.68 divided by standard deviation, 0.16, and we take a z-score for each of these values. The 8.5 is here, the 9 is here, and we're finding the probability z is between negative 1.13 and 2. Find our values, subtract to get the area in between, and then we get 0.8480, or 85% chance Mr. Starnes' tea will taste right. Here's another example. We have bag filled with apples. What's the probability the sum of the weights is less than 100? So we, again, would figure out our normal distribution means. So we add them all together. Each one has a mean of 9. We get 108. We take the variance. Remember, use variances, not standard deviation. First, add them all together. We get 27, square root of that, 5.2 ounces. We're finding the probability is less than 100. So using the graphing calculator, normal CDF we can use, we take a very long value here, remember, so we're using negative 99,999 to 100. So it's, where is it less than 100? Remember, use a big number here, so it works right. 108 is our mean that we just figured out. Our 5.2 standard deviation we just figured out. And note, to get full credit on the AP exam when using a calculator, students must clearly identify the shape, center, and spread somewhere in the work. Our conclusion: there's about a 6.2% chance that 12 randomly selected apples will have a total weight of less than 100 ounces. So remember, normal CDF is a different way to calculate it instead of using table 8. In the next section, we'll look at binomial and geometric random variables.